Design Online webinar from Eureka in association with Maxon. My name is Paul Fanning. I'm the editor of Eureka. And today's presentation concerns the future of motors in aerospace and will be brought to you by Andrew Gibson, Aerospace Sales Engineer for Maxon, UK and Ireland. Now, shortly I'll hand over to Andrew, but before I do, I should just mention that if you have any questions during the presentation, please type them into the box on the right-hand side of your screen, and we will hopefully be able to answer them at the end. If we're not able to answer your questions today, we will be handing them on to Maxon, and they'll be able to answer them for you offline. So with that, and with no further ado, I'd like to hand over to Andrew. Andrew.
Thank you, Paul. Good morning, everyone. Thank you very much for that intro. As Paul mentioned, I'm the Aerospace Sales Engineer for Maxon here in the UK. I link into the wider global aerospace team for Maxon. And I'm going to talk to you this morning about the future of motors in aerospace. That's some things will be quite near future, and then we'll be looking at sort of quite a bit further in the future as well. Firstly, and just a quick introduction to Maxon. So Maxon is a family-owned business that was established in 1961, and the headquarters are in a small village called Saxon in the heart of Switzerland. We are a true global business. We've got over 3,000 employees worldwide, and we're manufacturing over 5 million motors per annum. That's 20,000 motors a day in a huge number of different configurations. So within Maxon, we've got our own winding manufacturing. We manufacture our own gears and design our own gear heads. We manufacture and design our own sensors, as well as our own electronics. And then within the manufacturing processes, we've got a lot of the processes that we need to do in-house as well. So how do our customers engage with us? So Maxon has a significant catalogue of motors and parts. So it's over 500 pages long. So within there is the motors, the gearboxes, the sensors, the motor controllers, all the building blocks to sort of motor drive systems. But what we realise is not everyone wants product that is straight from the catalogue. So 80% of what we supply globally is modified from the standard catalogue products. These can be quite simple modifications, such as sort of shaft modifications, changing the length of the cables, putting a different connector on, to more complicated with quite bespoke flanges for customers. So these are what we call our semi-customized products. And then beyond that, we get involved with projects where we're looking at sort of quite significant builds as well, where we're looking at a bespoke solution for a customer. So these are based on the standard internals. So a lot of the products are manufactured in volume. So if we're looking at the gears, the windings, the bearings that we're buying in, we have got the economies of scale there. So we can do quite cost-effective bespoke solutions for our customers. And as you can see along the bottom there, we're quality assured to ISO 9001 as standard. And for our aerospace, we do have the EN 9100, and we also get involved with medical as well. So we've got the ISO 13485. So Maxon have been working in the aerospace arena for many years now. So we supply a mix of flight critical and what we would class as customer comforts products. So when we're talking about flight critical, we've got the feedback for the cockpit control side sticks, the fuel valve actuators, and then when we're looking at customer comfort. We've got the seat actuators, environmental control systems, the sort of air conditioning, and the valves in the bathrooms and things like that. We also get involved in the military aerospace arena as well, but due to a lot of the confidentiality agreements, we can't really divulge or show pictures of these products. But we are involved in things such as radar drives and optical payload drive systems as well. And then if we look at our space heritage, so Maxon has landed a real coup in working with NASA on the Mars exploration rovers. So we've been involved with NASA on the Mars exploration rovers for 25 years now, right from the very first rover that NASA sent right through to the mission 2020 with Perseverance and Ingenuity, the helicopter. Over the years, our products have been used in a variety of different parts of the rovers, from wheel drives through to solar panel deployment to, in the Perseverance, how our products are used in the sample handling system. So this mission is a multi-mission. So Perseverance is just the first part where it's drilling core samples, and then it's going to store those, and then later on the future missions will return those core samples to Earth. We had motors on the Ingenuity helicopter, so our motors control the swash of the rotor blades, allowing them to steer the motor around the planet. And then if we're looking at satellites and spacecraft, we have been involved in some quite prestigious missions. So the image there on the bottom left, that is the Lucy mission that launched later on last year. So that is going out to Jupiter and is going to be looking at the asteroid field around Jupiter. So on there we've got the solar array deployment mechanisms. We're also on the solar orbiter as well, so that's going the opposite direction. That's going to be the closest fly past of a man-made object to the sun. So that's going to get really quite hot. So we've got some product on there which are attenuating some doors so they can take the images of the sun's surface. And we do lots of products such as sort of inertia wheels to steer satellites. So what does the future hold? Well, I believe that sort of the next decade and 2 decades, they're going to be really exciting times for the aerospace industry. So we're going to start looking at drones. So drones are uncrewed air vehicles. They're not new technology. They've been utilised in the military arena for many years now. But now they're becoming more utilised in our everyday life, more and more. So there's quite a number of applications where these are going to be used. So we're looking at freight and deliveries. So we all know that the likes of Amazon are looking at drones for delivery systems, but they're also being looked at for fixed wing drones for carrying freight to sort of between hubs. And particularly for a country like the UK where we have quite a number of remote islands, we can get products shipped out to the outlying islands much easier and quicker than we can by using road. Search and rescue, so various different things in the emergency services. If you think of things like mountain rescue, where they're going to be looking for casualties, with a drone, they can cover a much larger area quicker than they can on foot. And then the emergency services such as the fire brigade, they'll be able to use drones to sort of see a fire from overhead, so they can plan how to fight that fire better. And then you've got police searches as well. Mapping and surveillance. This is sort of different things. So we can cover large areas for companies such as Ordnance Survey, where they can sort of scan and image large areas of space. Usually that will be done by people in helicopters, but that is expensive, so they'll be able to do it much cheaper. But also mapping underground caverns and tunnels and things like that. Making sort of looking at what is down there, so they can go down and scan these underground areas, safely without putting people at risk. Drone use in agriculture is likely to be quite a big thing in the future. So it's great to give farmers the opportunity to look at their crops and see how they're progressing, making sure they've got the good germination across the field. Without they can see it much easier from above without walking through the fields. But then there's also the spraying as well of the feeds to make sure that they do get the yield from the crops that they want. And then sort of inspection. So around UK there's a lot of offshore wind farms and more planned for the future. So those turbine blades, they need to be inspected on a regular basis. And so these can be done much quicker and easier with a drone. But then there's also pipeline systems as well. So there's many miles of pipelines across the globe which need to be inspected as well. So we can utilize drones and do it quickly and cost effectively. So if we look at the motor requirements on the drones, so first and foremost, propulsion. Yeah, it's both fixed wing and the like on the right there, the hexacopter. They've got electric propulsion. So we're looking at sort of green, clean, environmentally friendly products. And then we've got the payloads. So camera systems, so stabilized camera pan and tilt systems, so they can take the images that they want, whether that's with cameras, thermal images, or using LiDAR systems. So those all need to be actuated. Undercarriage actuation. So on a traditional aircraft, that's still carried out by hydraulic systems. But if we're looking at sort of electric aircraft, then that will be actuated by electromechanical means. And even the hexacopter on the right there, so the legs on that, they raise up to a horizontal position, which gives the camera the full 360-degree images around. And then on a fixed wing drone, we've got the flight control surface actuation as well. So steering the vehicle with the ailerons, the tail, making sure it travels to its correct destination. These wings are thinner section than what we would see on a much larger aircraft. So we need to get in the smaller actuators in there, which can all be done by electromechanical actuation. So moving on from drones to what we are likely to see as the next big thing, or the big change in society, urban air mobility. So what do we mean by urban air mobility? So this is the use of small electric flying vehicles. So these are used in a number of different applications. So there'll be the inner city taxis, where you can do short hops around cities. And then if a lot of the cities around the world, their main hub airports are outside the city, and people want to travel from the airport into the city centres quickly. So we'll have sort of airport to city centre transfers, and then looking sort of to short intercity hops as well. If you think of sort of a journey from London to Leicester, currently you're looking at 2 hours in a car if you're lucky. Now if you're travelling in an electric aircraft above the main traffic, you'll be able to do that in a much shorter period of time. So it is exciting. I mean, I look back, one of my favourite films of all times is Blade Runner, the original one from the mid 1980s, and never in my life did I expect to see flying vehicles around our cities, but it is coming. And sort of looking to the next Olympics in Paris in 2024, they are working on having an urban air mobility system in operation for the Paris Olympics. So it is closer than what some of us might think. So again, looking at where motors are going to be used on these platforms, again we've got flight critical and we've got passenger comfort. So these are all eVTOL aircraft. So when I say eVTOL, that's electric vertical takeoff and landing. So they've got the electric motors for providing the propulsion. It doesn't matter whether they're whether they're hovering vehicles like the top one that don't have the fixed wings, or if they do have fixed wings, they'll still have electric propulsion. Where there is wings, again we've got the flight control surface actuation. So those will control the ailerons, tails, to allow the pilot to fly and direct the aircraft to where he wants to go. And again, if we're looking at fly-by-wire systems, there will be some forced feedback in the flight control system, flight control sticks. So the pilot has that feedback, so he knows when he's pushing the aircraft. And undercarriage actuation as well. So when we're looking at electric aircraft, they need to be efficient. So the last thing you want is your undercarriage protruding and causing extra drag. So those will sort of be actuated inside the aircraft by electromechanical motorized actuators. And then looking at passenger comfort, these are new futuristic aircraft. So the world's the oyster, and it's what these companies want to do. So we've got door actuators. So the pilots will press a button, and the doors can actuate open, and then seat actuators. So not just your backrest and so your height and things like that, but can in the cabin, can the seats rotate so you can have a meeting while you're travelling as well? It's a new generation, it's a new world. The world is our oyster in these platforms. So if we're looking at sort of main passenger aircraft, so we'll never see electric propulsion of a large passenger aircraft. It's not practical. The mass of batteries would just be way too much. So although there's a lot of work going on at the moment within the industry, they do know they need to reduce CO2 emissions. So they're working hard on hydrogen fuel for aircraft, but that is many years in the future. So what they can do right now is look at reducing weight. So if they can reduce the weight, they can reduce the amount of fuel that they're using. But unfortunately, the airspace industry is is quite slow to take up new technologies. It's ask anyone who works in the industry, and they will be openly admitted that they are slow to change. But areas that are being worked on are electric actuation. So currently the flight control surfaces, they're actuated by hydraulic actuation. Now hydraulics, by how they work, having a reservoir of oil, they are quite heavy systems. So by changing to electromechanical actuation, you can reduce quite a significant amount of mass from the vehicle. But this is still, it's being looked at, but it's a long way from being common. And then if we look at inside the cabin as well, what can be done. So if you look at the seat actuators, if you move to small power dense motors such as the Maxon product, you can get your power from as small a motor as possible to reduce that mass inside the cabin. And then looking at sort of minimizing the amount of fuel as well. It's amazing how much fuel is used by an aircraft just literally when it is taxiing around the airport. So there is green taxiing, so electric green taxiing, where they're looking at putting a motor in the front wheels of the aircraft. So the aircraft will taxi out to the end of the runway under electric motor, and then the pilot only needs to switch his engines on literally when he gets to the end of the runway, and that can save a significant amount of fuel. And then moving on to space, and we'll start looking at space with human exploration. So there is talk of man returning to the moon, and whether it's in my lifetime or not, then manned missions to Mars. So they are looking at using the moon as a staging point for the Mars missions. But if they're making habitable colonies on these planets, there needs to be sort of work done prior to man arriving. So we're going to be looking at potentially robots sent out to prepare and build the habitation areas ready for man to arrive, and then once they're there, there's going to be the requirements for rovers and buggies, etc., for getting around, and then they're going to need solar panels, so they'll want to align those accurately to the sun to get the most power they can for as long as they can. And then communications with Earth, so there'll be things like satellite dish actuation as well for maintaining the communications. And then sort of more unmanned space exploration, deep space exploration, and satellites and spacecraft. So we've just had the James Webb telescope that's been launched, and that's got quite a number of motors on there. So they actuate all the segments within the mirror for taking the images. So if we're going to be looking further, we will look to have bigger mirrors to collect more light and see further. But these systems are long-term programs as well. So there will be motors involved in these, but they've got some quite harsh requirements. So in space it's very cold. So we need to make sure that the products can handle the cold temperatures. They're also operating in a vacuum, which again gives designers some problems to solve. So we need very special lubricants and sort of prevent any outgassing and things like that. And then there's a lot of radiation. Here on the Earth, we're protected from the solar radiation to a certain extent by the atmosphere of Earth, but out in space, the products do come in contact with a lot more radiation, so they need to be hardened for radiation as well. But if we're looking at these things, there's very much similar to the products that we have produced already in space, but they'll be sort of looking for more in the future. So there'll be reaction wheels, solar array deployment and alignment mechanisms, telescope alignment. So quite a lot of applications for motors for these sort of prestigious future space missions. And that's it from me. Is there any questions?
Thanks very much, Andrew. That was great. We do have some questions for you. I'll start with this one. You stated that the aerospace industry is slow to change to newer technologies such as electromechanical actuation. Why is this?
Okay, so the aerospace industry, particularly when you're looking at passenger aircraft carrying hundreds of people, they are very safety conscious, and what they have using if we look at the flight control system as hydraulics, they know it well. It's worked well for many years, and then just changing to something like electromechanical actuation, it brings in a whole new series of failure modes that they need to become familiar with. So literally they will spend many years testing, developing before they get to a point of being comfortable at putting this type of big change onto aircraft. I mean, you only need to look at the 737 MAX issue with Boeing, and so that's and that's why they've got even more safety conscious in sort of the last few years. So they are careful, and they want to make sure that us as passengers are as safe as we possibly can be.
Okay. Next question. Do you think there will be a limit to what can be delivered by drones?
It's all down to size. So what you've got is on a drone, you've got a number of motors and propellers which give you an amount of thrust. So you've got the thrust there to lift the platform itself, and then you've got the thrust then for the payload or whatever's being delivered. Now, if you increase the payload, you need to increase the amount of thrust. So you're then making a bigger platform. You've got bigger motors. You've got bigger propellers, and then as a result, you need bigger batteries as well. So as you're going up, the platform itself will grow exponentially. So to deliver an extra 5 kilos, the drone will be quite significantly bigger. So do we get to a point where we have drones the size of helicopters landing in the road outside our houses? I think they are nice, convenient platforms in the current sizes, but there is a limit to what they can deliver. So do I believe, and there are trials going ahead where they're delivering product for supermarkets out in Ireland, do I believe that we'll be getting our monthly shop on a drone delivery? I don't think so, because that's going to need a significant size of drone because of the size of the propellers and the batteries required as well. And again, we've got the safety aspect as well.
Okay. You talked about drones delivering freight between hubs, but these will be much smaller than trucks on the road. How can that be efficient? How can this be more efficient?
How can it be more efficient? Yeah, it's a good question. So yes, they'll be smaller, but significantly quicker. So you've got a truck on the road. It's limited to 60 miles per hour, and then you've got your driver brakes as well every so often. Whereas you can have a smaller drone that's traveling 300 miles per hour. so it can get that freight delivered much quicker and do multiple trips in the same time as one sort of articulated truck on the roads has done one delivery. So it's purely down to speed that something smaller can be more efficient and spread out as well. So from a hub and going out in different directions as well. So I think it can be efficient mainly because it can be a lot faster.
Yeah. And then it's the question of safety comes along inevitably in these situations. So in a world where we have flying taxis, maintaining passenger safety would be much more difficult as the consequence of breaking down or accidents would be much more severe. How can this be addressed?
Yeah, so if we look at the urban air mobility arena market at the moment, there's a lot of companies working on this. But at the same time, we've got the likes of the Civil Aviation Authority and the Federal Aviation Authority. They're looking at how to regulate this type of flying vehicle, the same way as they do with passenger aircraft as well. So there will be strict safety guidelines that are going to be put on, and it's one of those that a lot of companies have come into this arena. How many will make it long term is an unknown. When the regulations start getting more and more stringent, and set by the likes of the CAA, but it will be safe. It has to be safe because if it isn't safe, people won't use it. So the people who are working on this, they know that this, they've got to have that safety factor built into the platforms, and so that level of redundancy that is already there in other aerospace platforms.
So I mean, the final question really comes to it relates to that really. I suppose it's how safe will the sky be with all these flying taxis and drones? Are we moving the problems from the earth to the sky? And do we need to walk around with one eye looking up all the time? No, it is. There's a lot of work going in. So all these platforms will have sense and avoid systems in there. Again, the CAA are sort of they're looking at this longer term to have all the systems in place to make sure that two drones can't crash into each other. They'll be able to sense each other and steer around each other, and that's what we need to do. We particularly with these autonomous systems. And again, a lot of these platforms will still have a human element in there as well. So if you've got a pilot, a skilled trained pilot, then he's got that inbuilt sense and avoid. So they know what they've got to do. The regulations as to who goes up, who goes down. That's already there for passenger aircraft. It will come in. So I mean, yes, I'm not going to sit here and say there'll never be any accidents because there will be. It's just part and parcel of it. But I think it will be relatively safe. Okay. On that optimistic note, we'll bring it to an end. Unfortunately, we don't have any time for more questions. But as I said earlier, if you did put a question to us and we haven't had time to answer it, we will be passing those on to Maxon and they'll answer them for you offline. And with that, it just remains for me to thank Andrew and to thank all of you for joining us. Thank you very much.
Okay, thank you, Paul.